Okay, write the products of the following acid-base reactions. Okay, so how do we go about thinking about this? Well, you have CH3OH plus H2SO4. So H2SO4. Now, the easiest thing to do in this case, and this is kind of tricky because if you don't have a lot of experience with these kinds of reactions, it's hard to know where to start. But the first, I guess, the first approach would be to ask, are there any obvious acids or bases? And you should probably remember from general chemistry that H2SO4 is hydrochloric acid. I mean, it's hydrochloric. Sulfuric acid. Okay, so sulfuric acid, it sounds like an acid, right? It even has acid in the name. So when that is the case, that really tells you that that's probably going to be the acid in the reaction. So if that's the acid in the reaction, then obviously this must be the base. If this is the acid, then this must be the base. So if methanol, CH3OH, is the base, that means it's the one getting the proton, and sulfuric acid is the one giving up the proton. So then we can draw the products. Now, where is that proton going? The only place it can go is onto a lone pair, or some pair of electrons. And the only pair of electrons that's available is this lone pair on the OH, so we would write this like this, where you have OH2, the remaining lone pair, and then a plus formal charge. And then if you want to complete it, we've lost a proton from H2SO4, so that gives us HSO4 minus. So that problem was approached with this simple question, are there any obvious acids or bases? Now, how about in this case? CH3OH plus NaNH2. So NH2 minus is this species here. We can put the plus and the minus. In fact, we don't even need to. Sodium is the spectator ion, the counter ion. We don't even need to write it out because it may sort of confuse us or just kind of distract us from what's really going on. So let me put this a little closer here. NH2 minus. So even if you don't know of this as a base, it is probably acting as the base in this reaction because it has a negative charge. So this first strategy here still applies because the base, strong bases, generally, not always, but generally have a negative charge. So let's just try the reaction where this is serving as the base, this NH2 minus. So let's call this the base. And then this, if this is the base, then this must be the acid. And we already saw how alcohols, just like water, can be acids and bases. So here, if the OH is acting as the acid, or if the alcohol is acting as the acid, which one of these protons is acidic? Well, we already know from the element effect that we just talked about that the negative charge prefers to be on the most electronegative atom. And so in this case, we have a choice to put a negative charge on carbon or a negative charge on oxygen. And since oxygen is more electronegative, we'll put it on the oxygen. So that will give us a CH3O. And it may help you to write out the lone pairs so you can keep track. And if we pull off a proton from CH3OH, we get CH3O minus. And then NH2 minus goes to NH3, which is neutral. So notice that we've conserved the charge here. There's a minus charge here, and a neutral molecule, methanol is the neutral molecule, with a minus charge on the base. Now we have the conjugate base with a minus charge, conjugate base of our acid. And now this is the conjugate acid of our base. Okay, let's look at part C here. CH3NH3 plus Cl minus plus NaOH. So CH3NH3 plus and Cl minus, so I was a little bit confused there. This is the molecule on the left side of the equation, and it's reacting with sodium hydroxide. So this is methylamine hydrochloride, it's one way to call it, one way to name it, plus sodium hydroxide. And again, I prefer just to sort of focus on the chemistry at hand to not get the spectator ions involved. And NaOH is this, right? Essentially, from the standpoint of what's taking place, we have an OH minus. So again, if we look at ask ourselves whether there are any obvious bases and or acids. In this case, since we know hydroxide, just intuitively, we've probably heard that sodium hydroxide is a base. We can start by assuming that this is the base in this reaction. And so if we assume that the OH minus is the base, where is the acid? Well, if we pull off one of these protons from NH3 plus, what do we get? So let's just draw out the product here. CH3, NH2, and a lone pair, plus, and if hydroxide pulls off a proton, we have OH2 water. So that leaves us with chlorine or chloride hanging out as a counterion. And we also, remember, had sodium in there that we kind of ignored, and we'll put it back because we want to make sure we're conserving the charge here. So I'll just put sodium here and in the product, just to keep all of the charges conserved between the left and the right side of the equation.